Hi folks, good morning. Mr. Long here. We're going to do a screencast today on getting tangent slope functions from the limit definition. So this follows along with what we've been working on. So far we've calculated the slope of tangents at specific x values on a curve. Now we're going to generalize this and use the limit definition to get an actual equation of the tangent slope function, the hard way. So just to go through the pieces of this again, this equation, which you're familiar with, it's called the difference quotient. So this value here we call, in this case, we call it x. This distance from A to B we call h. That distance is h, which happens to be the run, of course, of the slope triangle. The y value at A is then, oh, by the way, this is x plus h, right? It's h to the right of x. So the y value right here, which is the same as the y value right there, is the original function f, and I sub in x, right? So I'll show you that. So what I do is I go from x, I go up and I hit the curve and come across, and that's the y value there. Then I've got up here at B, I'm subbing in, right? I'm subbing in the x plus h, and I hit the curve, and I apply the rule f, and I get the y value. So that y value is f at x plus h. So it follows then that the difference in these is f at x plus h minus f at x. And so that's the difference in y, and the difference in x is h. And that's, folks, where we get this f at x plus h minus f at x. So what we want to do, right now we've got a tangent, right? We've got a secant, rather. It passes through 2 points. So what I've got to do is I've got to take B and move it slowly, 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 slowly towards point A. So we go from B to A. If we reach A, we've got a tangent. But the problem is that h is getting smaller and smaller and smaller and smaller. And in fact, to truly have a tangent, h has to be 0. Since I can't let h be 0, I do what's called a limit, and I get as close as I possibly can without actually reaching it. And through the miracles of algebra that you've already seen, we can actually get rid of division by h to create a tangent slope function. All right, so let's actually try one. So we're going to start off with the simplest one. We're going to do f at x squared. So I'm going to give you my strategy for this. There are many different, you can look online, there's millions of YouTube videos. I'm going to make a suggestion for you with how to do it, and you know what? You can do it in whatever way you like as long as you're showing all your work. By the way, we already know the answers to these. F prime at x is 2x, right? We know that answer from the power rule. So that's going to be our answer when we get to the end of this. So first things first, I need to figure out what f at x is, and I need to figure out what f at x plus h is. So I go over to here, and f at x is x squared. And now, everywhere before where I had an x, I have to replace it with x plus h. Okay? This one requires simplification. So this is a squared plus 2ab plus b squared. So that's going to work out to x squared plus 2hx plus h squared. Okay, so that's what that is. So now we have f at x plus h and f at x. Now, the thing is, if we look over here, we call this the difference quotient. I need to subtract those two. So I'm taking this and I'm subtracting off f at x. So the nice thing is there, I know there's x squareds in both, so they're going to cancel out. What I'm left with is 2hx and h squared. So that's f at x plus h minus f at x. So I can go to the next line and I can actually write that. 2xh plus h squared, all divided by h. But the thing is, I can actually break that down into two separate fractions. I can write that as 2xh over h plus h squared over h. Now, a lot of people just do this by factoring. I find it simpler to do it by division. So then the h's divide out there, and the h's divide out there. So do I still have division by 0? Because remember, h is getting close to 0. No, this gets rid of the division by 0. So now what I have is, I can say, finally, that h equals 0. And f prime of x will equal 2x plus h, this h here, but h is worth 0. F prime of x is 2x by the limit definition. Okay, we're going to try one more. And again, pause, rewind, go back over this. Oh, whoops, this is not the one I wanted. Okay, well, I somehow made a mistake there. I'll call this b. And for b, we're going to do, I'm going to do f at t equals 2t squared minus 3t plus 1. Okay, that's what I'm going to do. So let's go ahead and do this. So now this one here I'm going to have to change, right? Because I've got this definition here in terms of x. So that's going to have to become a t. That's going to have to become a t. That's going to have to be a t. And so is that. Okay, so everywhere I see an x, I'm replacing it with t. And again, the goal is to get the tangent slope function. So here we go. So the first thing I'm going to do is write down my original function, in this case f at t, 2t squared minus 3t plus 1. Now, everywhere where I saw a t before, I have to replace with t plus h, or normally be x plus h. So I'm replacing that with what I see here. So t plus h, t plus h. Okay, I'm replacing that. Now I need to simplify again. And this does require some reasonable simplification. So 2, and then I need to know how to do a perfect square expansion really fast. T squared plus 2ht plus t plus, plus h squared. How about I erase that and make it legible? Plus, by the way, why do I put the h first? Because t is like x, and you always want x to come at the end of a term. So plus h squared, and here I need to expand through those brackets, so minus 3t minus 3h plus that 1 at the end. And the last thing is to expand through this bracket, 1, 2, 3 times. So it's going to become 2t squared plus 4ht plus 2h squared. And then I get the rest of this stuff here, minus 3t minus 3h plus 1. Okay, so now what I do, remember, is it's f at x plus h, or f at t plus h, minus f at t. So the neat thing is, remember, you're going to get rid of anything that's the same. 2t squared, that's gone. So now I'm going to look for negative 3t, because it's going to be there. It's gone. I'm going to look for 1. It's gone. Whatever's left over is f at t plus h minus f at t. Well, it's always going to be the parts that have an h. That's got an h in it, that's got an h in it, and that's got an h in it. Okay, so let's go back over to here. And what I want you to do now is get used to just writing it directly into fractions right away, okay? Like separate fractions. So you're going to write it as 4ht. So 4ht, and then you're going to divide by that h, plus 2h squared. 2h squared divided by h, plus negative 3h. Well, I don't think I need that plus sign there. Minus 3h divided by h. Okay, so now what I can do is simplify. So the h's divide out there, h goes into h squared h times, and that goes out. Do I have division by h anymore? No. So I have now no need for a limit. I can actually get to h equals 0. I don't have to just get really close to it. It's important for me to state that h equals 0 at this point, and now I can write that f prime of, t in this case is 4t plus 2h, and h is worth 0, minus 3. So overall, f prime at t equals 4t minus 3. Now let's look and see if that's reasonable. What was our original question? That right there. F at t equaled 2t squared minus 3t plus 1. So what we have here is that we know right away f prime at t is 4t minus 3, right, from the power rule. So it agrees. Again, that's the nice thing. We already know the answer to these when we do these questions. That's one of the reasons I do the power rule first, so that students can check and verify their answers. All right, folks, so you're going to practice some of these quadratic ones, and there will be some cubic ones you can try as well if you want. That's it for today. So good luck in doing your practice questions.